Okay. Now I'm recording this, okay? So the derivative of b to the x, okay? Yeah, b to the x equals what? b to the x times by what? ln b. Okay? Yeah, you see the derivative for the log function, it is 1 over x times by ln b. Okay? So this is the formula for exponential function, for natural exponential function, okay? Logarithm function, regular one, natural logarithm function derivative, okay? And then, okay, from the previous video, okay, we know that for log function, in general, this is a regular log function. There are two cases: if the base b is greater than 1, if the base b is between 0 and 1. And for natural log functions, y equals ln x, okay? So these are the formulas, okay? And then these two are the formulas for derivative of the log functions. So we're using the formulas to do calculations, okay? And a lot of times, okay, the derivative of the log functions are combined with what? The chain rule. Okay, say the example, we have ln u. U equals what? U is a function of what? U is a function of x. So the derivative of ln u equals what? Derivative of ln u gives us what? 1 over u, right? And then by using the chain rule, we have to multiply by what? du dx. Okay? Or, if we're going to differentiate what? ln g of x with respect to x, what do we do? By using chain rule. So the derivative of ln g of x should give us what? 1 over what? 1 over g of x. And then times by what? Derivative of g, right? So that's g prime of x. Do you see that? Yeah, okay. So combining with chain rule, we may have these formulas. Okay, these formulas. Now let's look at the specific examples, okay? Differentiate the functions. We have question A, B, and C. Okay, so I would say that I will let you practice one. Okay, let's do two. Okay, so we're going to do number B together for sure. Okay, so for A and C, how about you pick up one from A and C? We do one together with B, and you try the other by yourself. Do you want to try A together or C together? Let's do A together, and then you do C, okay, later in group, okay? Alright, so, differentiate the function. G of x equals ln of x times by square root of x squared minus 1. Compute the derivative of g with respect to x. What's up?
To start, we're going to put 1 over whatever the
Yeah, you're right. The derivative equals, because this is a natural log function, ln of something, right? So by using the chain rule, at first, we're going to differentiate of ln of this is g of x, right? Well, this is a function, because this whole thing is g, okay? So this cannot be g, okay? So we'll have 1 over what? X times by square root of x squared minus 1, right? And then times by what? The derivative of x times by x squared minus 1. This is a chain rule, right? 1 over this thing times by this thing's derivative. Then what do we do next? 1 over x times by square root of x squared minus 1. Alright. Inside the parentheses, we have a product. So to differentiate product, we should use which rule? Product rule, right? Product rule. Differentiate x give us what? 1 times by square root of x squared minus 1. Plus, well, still keep the x and times by the derivative of square root of x squared minus 1. So how to compute this square root? Do we have to do that? Well, we can use the formula directly. Remember, I told you to remember square root of x derivative is what? 1 over 2 times the square root, right? So I'm going to use that formula directly, okay? So the derivative of the square root will be 1 over 2 times by the square root of x squared minus 1. However, by G rule, okay, we have to compute the x squared minus 1's derivative. Do you agree with me? 1 over 2 times the square root times by the derivative under the square root, right? Alright, so equals 1 over x times by square root of x squared minus 1, okay, times by 1 times square root x squared minus 1, right, plus this is x over 2 times by square root of x squared minus 1. What is the derivative of x squared minus 1? 2x. I read the 2x here. Okay, this 1x comes from this x. The derivative of x squared minus 1 gives us 2x. Right? And these two cancel out. And we know this x times this x gives us x squared, right? X squared. So see, outside the parentheses we have this. Inside the parentheses we have that. What do we do? Okay. Okay. Square root of x squared minus 1, still copying that, plus what? X squared over square root of x squared minus 1. Everybody, you go with this? Are we able to simplify this whole thing? Can we distribute this thing to each term inside the parentheses? Yes, let's try that. First, let's distribute 1 over x times x squared minus 1 times by what? Square root of x squared minus 1 plus, you guys, then we distribute this thing, which is 1 over x times by square root of x squared minus 1 times by what? X squared over square root of what? X squared minus 1. Can we simplify? Yes. How? Square root. Yeah, x cannot be 1, okay? Or negative 1. Because if x equals 1, we have to make sure the square root cannot be 0, right? And x cannot be positive or negative 1. If so, we'll have ln 0. ln 0 is infinity. So that means from this given log function, we are able to cancel out the square root of x squared minus 1. Yes, we are able to. Okay. Now we have 1 over x plus, what is this? This x and this x squared can be simplified by like this, right? And what is square root times by square root? It becomes this, right? No square root, right? Square root times by square root. Square root is gone. Now, you can leave your answer here, okay? But if you want to write for one more step or some more steps to simplify it, how? Common denominator. What is common denominator? X times by x squared minus 1. Right? So the first fraction you can write x squared minus 1 over x times by x squared minus 1. For the second fraction, we need to multiply by x from both top and bottom, right? And then now common denominator, right? Same denominator. X times by x squared minus 1. X squared minus 1 plus x squared give us what? 2 2x squared minus 1. Are we able to simplify the top and the bottom further? Yes or no? No. Done. Okay.
Question,
Sure.
why do we have to use the chain rule a second time up there?
Well, because we want to differentiate the square root, right? So, we have to use the chain rule. We're talking about just this part only, right? So how to do the derivative for this function? Can we just say this equals 1 over 2 times x squared minus 1 done? No! If this is x, 1 over 2 times square root of x, done. But if this is not x, this is something, a function h of x. So we have to combine the chain rule, right? So 1 over 2 times square root of this times by the derivative of what? H. What is h? X squared minus 1. So that's why this whole thing is a result from the derivative of the square root of x squared minus 1. Yeah, it doesn't say that chain rule you can use it once. It depends on whether you have to use the chain rule or not. If so, you have to keep on using chain rule. Sometimes in the one question you may have to use chain rule several times. Depends on the given function. Can we move on to question B? Question B. Differentiate y equals 1 over ln x. 1 over ln x. Any suggestion? Quotient, right? Quotient rule. Square of the denominator. Then, on the top, differentiating the numerator, give us what? 0 times by the denominator. Minus numerator times the derivative of the denominator. What is the derivative of ln x? 1 over x, right? So 0 times ln x is 0, nothing, okay? So on the top, we actually have negative 1 over x over ln x squared, right? And then 1 over x, okay, so we can rewrite this thing as negative 1 over what? X times by what? ln x squared. Done. See, this is a easy question, right?
Why is the derivative 0 at the end of the numerator?
It's the derivative of the constant.
Because the derivative of 1 is 0.
Okay.
You still remember the quotient rule, right? You have the differential of the numerator, then times the denominator, minus the numerator times the derivative from the denominator. So that's why we get a 0 here and 1 here. Alright, question C. Similarly, okay? You're going to try this one in your group work, okay? So, yeah, you will have time to do this, and I will show you the key for question C, okay? Alright, so this is the first part of section 3.6, derivative of log functions. And you can use these formulas and then combine with the chain rules and then do most of the, derivative differentiation questions. It looks like this, okay? Second part from this section, we talk about what? Logarithmic differentiation, okay? Yeah. This is not implicit differentiation. Remember, we learned about implicit differentiation. Now we're talking about logarithmic differentiation. I'm telling you, I will give you exam questions from the log differentiation. Be prepared for this type of question as well. Okay? Alright, so how to do log differentiation? Okay, so you see, the examples looks like this, okay? Use log differentiation, okay? So, most of the questions for log differentiation, they will tell you directly, use log differentiation, okay, to find the derivative of the function or some other methods, okay? So, they will tell you, use log differentiation, okay? What kind of functions? Y equals x to the x power.
exponential, right?
How can we differentiate? Can you find any rules to do it, like a power rule or like an derivative or exponential function or any rule to do this? No way, okay? For power rule, you have to know what? X to the nth power, n is a constant, power rule. For exponential function, we do what? Constant b to the x power, okay, b is a constant. So there must be a constant for either exponent or what? Base. But for this function, x to the x power, both the base and the exponent, they are variables. How can we find a derivative for this type of the functions? We have to use log differentiation. Okay, power rule doesn't work. Exponential function doesn't work. Okay. Or questions looks like this. Okay, you see, y equals x to the sin of x power. Okay, on the base we have variable x. On the exponent we have what? Sin of x, which is a function of x. See, y equals cosine of x to the x power. Cosine x is a function of x. Exponent is also what? X. So this type of the question, how to find the derivative for this type of function, what do? We use log differentiation. So we have 1, 2, 3 steps. I'm going to ask volunteer to read the 3 steps, and we will follow the 3 steps to do the calculation. Okay, Dylan, can you read?
Take natural logarithms of both sides of an equation, y to the f of x, and use the laws of logarithms to simplify. Differentiate implicitly with respect to x. Solve the resulting equation for y prime.
Okay, very good. Okay, so step 1, take natural log of both sides of the equation. What's natural log? Do you remember? We just reviewed. Natural log is what? Ln, right? Natural log is Ln. Take Ln function, Ln, okay, from both sides of the equation. Okay, we have question A, B, and C. Okay, so I'm going to use some examples for us. Okay, so let's try A and B. Okay, and you try C. Okay, you do C by yourself. Okay, so to find the derivative of this function, what do we do? First, choose natural log from both sides of the equation. So on the left-hand side we have ln y, on the right side we have ln x to the x power. And we may write the right side by x times by ln of x. Do you agree with this? If we have a something on the shoulder of x, right, we can rewrite it as what? X times by ln of x, right? Okay, step 2. Differentiate implicitly. Okay, implicit differentiate both sides with respect to x. Okay, so differentiate both sides with respect to x. Keep in mind that function y is a function of x. Okay, so the derivative of ln y with respect to x. Okay, let me write it this way. Okay, so in case later, okay, you forget, x times by ln x. Okay, so what is the derivative of ln y with respect to x? Ln y derivative, what should we get? 1 over y, right? But don't forget, y is a function of x, right? So you multiply by y prime, or you can write dy over dx, either way. Right side, x times by ln x, derivative, product rule. Differentiate x give us 1 times ln x plus x times by the derivative of ln x give us what? 1 over x. So simplify the right side, we actually have ln x plus what? 1. Are we done for the function? No! Step 3, solve for the resulting equation for y prime. Now on the left hand side we have 1 over y times by y prime. How to isolate y prime? How? Multiply by y from both sides. What do you think? So y prime equals y times by ln x plus 1. Can we say we're done? No. because y equals x to the x power. So don't forget to plug in y back by x to the x power, okay? So we should have x to the x power, ln x plus 1. Now we're completely done, okay? Because function y is a function of x, so the derivative of y must also be a function of x. So if we have a y on the other side, okay, we have to replace the y by x to the x power back, okay? Replace the y, original function y, into our solution. So this is answer.
So should I be the fourth step?
No, this is not the fourth step. This is still step 3. Solve for y prime. See, we multiply y from both sides and replace y by x to the x power. This is we can assume this is a one step. But if you want to add a step 4, say, replace y by, replace y by the original function f of x. It's up to you.
If we leave it just at this third step, will we be counted wrong or will we get partial?
You will not be counted wrong, but you will lose partial credit. Because, see, the function, it is explicitly a function of x. So the derivative of y must be a function of x. So, see, you're having a y here. So I would prefer you replace y by the original function.
Gotcha.
See, this is only in terms of x, not y. Can we try another question? Yeah, so I believe from this example, you should already have a brief idea about how to do log differentiation. The key step is what? Step 1. Choose what? Natural log from both sides. And then step 2, differentiate both sides with respect to x. Third step, solve for y prime. Okay. So question B, find the derivative of this function by using log differentiation. What do we do at the first, everybody?
Take natural log.
Yeah, take natural log from both sides. Okay, so left hand side give us ln y, right side give us ln of x, the sin of x power, and what do? We write this exponent in front of the ln x. Step 1, done. Step 2, differentiate both sides with respect to x. Left hand side, ln y, 1 over y, times by what? Y prime. You will see log differentiation, left hand side, most of the time looks like this. Ln y's derivative with respect to x, 1 over y times by y prime. Right side, what is right side? What's the derivative of right side? Product rule, right? Sin x derivative is what? Cosine x times by ln x plus sin of x times by the derivative of ln x gives us what? 1 over x. And then solve for y prime. What do? Multiply by y from both sides. Y times by cosine x times ln x plus sin of x over what? X. And then don't forget to replace y by what? X to the what? Sin of x. Okay, so you may want to write for one more step if you want to. Okay, so I'm writing everything in one step. Okay, so the answer is y prime equals x to the sin of x as an exponent times by the parenthesis.